Hello. This video is an example of ABC inventory classification, problem number 1. So let's bring up the problem. An ABC inventory classification of a 20-item inventory resulted in a classification of 4511 of inventory items and a total annual dollar usage of 123 for classes A, B, C respectively. Assume the unit ordering cost is $135 per order. Unit carrying cost is $4 per dollar per year. So there's the problem. So the questions down here, the statements, are basically creating a table of the ABC classification, a cost analysis, and the last one down here is a minimum cost inventory. So let's just build a table. So let's bring up Excel. And so we can see here that, well, in building Excel, we'll start here with the, come down a ways, enlarge this so we can see it. Class will be A, B, C. And then we're going to have the usage. And we have the usage right here, which for class A is 3,4,9,852. For class B is 6,5,156. For class C, it's 2,5,785. Okay, and then we have the classification of 4, 5, and 11. Okay, and then up here we're going to have the unit carrying cost and the unit cost, put it that way. Ordering is 135, 135, and the carrying cost is going to be $4 per item per year. Okay, so therefore the EPP will equal that will equal our ordering cost divided by carrying cost, which is going to be 33.75. Okay, so what I want to do here for this problem is simply just build a table. And let's center all these so we can see them, enlarge this so we can see what's going on. We'll just build a table. So this is everything. Well, first of all, I've already started here. This is the input. Okay, this right here represents our input. And then from this, now we can build our table. Okay, the first thing we do is the frequency. Well, the frequency also was given down here for an inventory policy of 22.14.11. For an inventory policy of 22.14.11. Inventory policy 22.14.11. So we'll do that one. 22.14.11. So for that policy, we'll build a table. Okay. And so let's just go ahead and do that. So we have the frequency. So the first thing is NF, the number of frequency, which is simply the N times F. N times F. The next then is going to be the average inventory. Okay, and that, if you recall, that equals the usage divided by the frequency divided by 2. Okay. And then over here, since this is, our EPP is this, but this would be the observed EPP, observed, which will be the average inventory divided by the number of orders. And then we copy that down. And so that's going to be the table. Okay, so then we come down here, we can say the sum of these and then we have the unit cost and then the total cost. Okay, the first is take the sum equals the sum of all the frequencies and all of the inventories. And there we go. Okay, now the unit cost is going to be $135 per order, and this equals $4 per dollar per year. And then we'll take the this times this and copy that over, and then that's the total. And then we have the sum equals this plus this, and that's how much this is going to cost us, $83,465. Okay, but then we can come down here and say, okay, let's see here. Let's take the optimal solution. And if you recall, the optimal solution for the frequency equals the square root of m divided by 2 times, whoops, open parenthesis, 2 times n in whatever class you have times your EPP. Okay, if you recall, that's going to be the optimal solution. So let's just bring this down here again. Let's go ahead and bring this down. And so now let's do the EPP again, which equals the ordering cost divided by the carrying cost. Okay, we did it again. Okay, now we want the frequency, the optimal frequency. Well, that's going to simply equal the square root of the usage divided by 2 times the n, which will be that right there, times the EPP, which is that, and we'll freeze that. And so there's the optimal. Then we can, I think we can copy that down. I think we have, does that look right? Yep, that looks right. Now we probably don't need all that, those significant figures. We can bring this down maybe to 2 significant figures. That's fine, maybe less even. But anyway, that's the frequency. That's the optimal solution. That's the minimum cost. So then we can come over here and say the NF, and then also the average inventory equals N times F equals this divided by F divided by 2, and bring these down, and then take our sums here. Some of these, copy these over, and then bring our unit cost down. Whoops. Equals this times this equals this times this, and then the sum. This times this plus this. Okay, and you can see how much we've decreased. We have this much. This much was for the 2214 policy, and then the optimal policy here, which is this, which could probably reduce that down, as I said before, to 36.14.6. That's going to be close enough. Yeah, 0.9.9. Just make it 36.14.6, and there's how much savings there's going to be. We'll take this minus this, and that's how much savings there are for the optimal policy. From the 22.14.11 to the 36.14.6, we're saving that much money. Okay, so now that we have this set up, this is optimal. We can put other numbers in here, and I think I do. I think down here it says the optimal inventory policy that minimize is this 30, 10, and 4, which are the annual order frequencies A, B, and C. Oh, Anyway, so the question, is that true? So all these questions down here can be answered from these two tables. I guess that's what I'm getting at. Okay, so this is the policy they're evaluating. This is the optimal policy, and so that's how you solve inventory ABC classification problem number 1. There'll be other problems. The ABC inventory classification is very robust in applications, and this is problem 1. There'll be other problems. So that's all I have.